Hello, everyone. Welcome to today's webinar, What's New in SingleStore Summer Release. My name is Diogo, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A function in the lower right corner of your console. We will answer everyone's questions after the presentation. After today's webinar, you will receive an email with the recording. If you wish to contact us, please email us at team@singlestore.com. So let me introduce our speakers today. We have Micah Bhakti, he's the Director of Product Management here at SingleStore. And we also have Eric Hansen, he's also the Director of Product Management here at SingleStore. Welcome, Mike and Eric, you now have the floor.
Hey, welcome to the webinar today. We're going to be walking through what's new in the SingleStore summer announcement that we've just made. I'm here today. I'm Micah Bhakti. I'm a Director of Product. And we also have Eric Hansen, who's also Director of Product with us. And so we're going to run through a number of the new capabilities that we've introduced. But first, we just kind of wanted to give a level set of what SingleStore is and what problems we solve for our customers. And then we'll go through some of the new features and capabilities that have been added into the product recently. So there's a number of things that we see kind of shifting in the market. As customers are pulling data from more and more sources, and as companies are more and more driven by data in order to make decisions about new products and services, as well as responding to customer demands, there's an overall increase in the volumes of data that companies are capturing and that they're using to kind of drive decisions internally. And businesses more than ever need to generate insights from data and need to do that in real time because the market is more reactive and there are more entrants that are competing kind of every day in each of the industry verticals. And so, for a long time, executives have kind of driven decision making from data on their customers and competitors and products. But now more and more, everyone within the organization is being expected to drive the same types of insights from data and from customer information, and to be able to do that instantaneously, right? If your customers start buying a new product today, you want to know about it immediately, not next week or next month. And if your service is impacted, you need to understand that right away so that you can remediate issues and not find out about it, hours later or days later. And there's an overall kind of shift because of the importance of these insights. Consumers of that data, executives, line managers, customers, they want that data to be fresher than ever. And so there's a shift from kind of getting insights and running analytical queries historically to moving to do that in kind of real time and needing to query data instantaneously as it's being streamed into systems. And then pushing beyond that into kind of predictive and using AI and ML models to determine what customers are going to do in the future or how markets are going to shift, next quarter. And be able to use that to make investment decisions or make new product introduction decisions. And there's a number of databases out there already. There have been databases in the market for a long time, but a lot of the fundamental design decisions about databases have prevented them from being able to keep up with some of these market trends. So these databases are typically built on legacy architectures, and they have sluggish, what we call event to insight response. So if you have data that's being used by customers directly, you might have certain SLAs on how quickly you populate that data for your end users. Or you may have dashboards internally that you've built as custom applications, and you want to understand, when your service is down or when customers are experiencing delays. And so to be able to create actionable insights and have somebody respond to that data, you need that to happen within an internal SLA. There's also overall rising costs and complexity of managing data within the organization. So as more and more different types of databases are created, there's rising costs of data management between databases and also increased costs by managing a sprawl different data solutions that are kind of designed for certain point problems or specific applications like time series or geospatial. And overall, one of the biggest trends that we see is an increase in the demand for concurrent access to data. So as data is kind of democratized within the organization, and everybody is using data to make decisions within the organization, you need the number of users that are trying to access that data to be able to be supported by the infrastructure. And so databases that scale out often scale out in data volumes, but not always in terms of concurrent access to that data. So SingleStore is the single database for data-intensive applications. And I'll talk a little bit about what that means. But essentially, we're a cloud database, and we've designed SingleStore to be able to handle both transactional workloads, like an operational database, and also analytic workloads, like a data warehouse. And so the benefit of that for data-intensive applications, for applications that you're building to deliver an experience to your customers, or you're delivering internally so that your users can understand the state of the business and how things are going. You have a number of different kinds of workloads that you need to run. You may need fast lookup and high concurrency with the operational workloads, and you may need fast queries across large volumes of data and aggregations in order to derive kind of insights from the data that you're ingesting and cataloging and storing. And so SingleStore is unique in this ability to kind of run both transactional and analytical workloads in the cloud. And we do that because of some technical innovations that we've introduced. We have an in-memory row store and an on-disk column store, and everything is persisted and durable. And it's delivered through a technical innovation that we have called universal storage that Eric will talk a little bit more about. So for our customers, what this innovation allows us to do is to deliver a multi-model database that simplifies their data architecture. So SingleStore is a fully relational database. We're MySQL compatible, but we also offer multi-model. So you can do geospatial, you can do time series, you can run full text search on data. And so our customers are able to consolidate their data infrastructure and reduce the number of different solutions that they're using, and do that without giving up the performance or the scalability of the solution. And so what that means for application developers is, rather than having to manage data silos between different solutions like MySQL and Elastic and Redis, you can run all of your operational and analytic queries directly on the data in SingleStore and not have to move that data around between different solutions for a single application. So it reduces complexity and it reduces overall cost of kind of managing the data architecture for these data intensive and data driven applications. So who are the customers that are using SingleStore for this today? We have a number of kind of tier 1 customers, Fortune 100 customers in the technology sector like Uber and Akamai, who are using SingleStore to kind of ingest data from all their devices and user experiences, and to use that to power custom internal applications that let employees know if there's service delays or if their infrastructure is impacted, and to be able to respond to those incidents immediately so that customers aren't impacted by changes in the overall kind of infrastructure state. We also have a lot of financial services customers. Many of these top tier banks that are using SingleStore are using it for risk analysis or for fraud detection. And they have large volumes of data that they're streaming in from different sources. And they want to be able to, understand if an individual trade has kind of adjusted the overall risk portfolio of the investment institution, or if customer transactions that are coming in fit with a customer's purchase profile, or if they're likely to be fraudulent and should be flagged. Perhaps they're using ML models that they've trained on fraud, and then running those against the live transactional data sets in order to generate those insights and alert customers or alert employees if events happen in real time. And we have customers across different sectors. We've got media and entertainment, Comcast using SingleStore for streaming analytics and prediction to help increase customer experience. or energy companies that are streaming data from IoT devices and need to understand at all times what the state of their infrastructure is, and to be able to do that immediately across thousands or millions of devices distributed around the world. So, in the to kind of further these capabilities for these enterprises and other commercial and businesses who are leveraging SingleStore in order to drive kind of rapid insights and build custom data-driven applications for customers and for employees. We've introduced a number of new capabilities into the product that we've announced this summer. So these are built around mission critical applications and drive the ease of use and flexibility of the platform, technical innovation in the architecture and the way that we've built SingleStore, and features to kind of lower the overall TCO of the solution and give predictable pricing, while maintaining the benefit that you can run SingleStore across multiple clouds or in hybrid environments between on-prem and public cloud. So there's a number of kind of key capabilities that we're going to talk about today. So I'll give a quick high-level overview of the investment areas, and then I'll turn it over to Eric, and he can kind of run through the specifics of how we've implemented these features, and then I'll go over a couple of the kind of ease of use capabilities that we've introduced. So at a high level, there's three main areas that we've invested in. Mission critical capabilities. These are for applications that are either customer facing or they're internal applications that employees rely on in order to guarantee the serviceability of the business. And so we've introduced a feature called point-in-time recovery, as well as a number of advancements in security and compliance to kind of ensure that the data is always secured at every level of the platform for these mission critical workloads. We also have some technical innovations. We have an industry first of delivering separation of storage and compute in a cloud database that handles both operational and analytical workloads. And we have the key kind of capability of universal storage, which allows us to manage data in both row store and column store to support both operational and analytical workloads. And then around ease of use, we've got capabilities for suspend and resume of active clusters that kind of supplement the functionality that we already had around elasticity and dynamic cluster scaling. And then we've also introduced a new flexible pricing model, which I'll talk a little bit more about, which allows you to kind of only ever pay for what you use and make sure that for workloads that are dynamic and changing, or for one-time or temporary workloads like development, you can manage your costs in a predictable way without paying for infrastructure that you're not taking advantage of. So I'll turn it over to Eric now to kind of go through some of the technical innovations that we've released in the engine.
Hey, thank you, Micah. So as Micah mentioned, we're introducing a point-in-time recovery feature in this summer release, and this is what it sounds like. It allows you to recover a database to any point in time. So you could recover to any wall clock time with any time granularity down to the microsecond, or recover to a named milestone. And it's oriented towards mission critical applications. So people that are running applications that need to be up all the time and have very high data integrity requirements need to be able to recover from some sort of database corruption or problem with their database. So if something goes bad in your database at 3:30 in the afternoon, you may want to recover to just before that time, to 3:29, say. This allows you to do that. So interestingly, it works with what we call unlimited storage databases, also known as bottomless databases, which I'll say a few more words about later. But it functions with a sort of continuous online backup. So the complete history of all your data is maintained over some window that you define, like a day, a week, a month, 90 days, whatever you choose. Will maintain all history of the data over that time, and you'll be able to, if something goes wrong, recover to any point in time during that sort of sliding window of history that you maintain. You still might want to do your own backups for compliance reasons or other reasons. So it doesn't completely obviate the need to do backups, but it provides a measure of backup capability automatically. And it really can provide peace of mind because you know that if something goes wrong with your database, you can get it back to a consistent state and restart your app and start going forward again. And it's actually quite easy to use. Simple commands allow you to recover to either a point in time or a milestone. And it's really quite fast as well. So you can recover to a point in time pretty quickly. Just the way it recovers is just restores most recent snapshots and plays the log back to the latest point in time. And it doesn't actually have to reload all the column store data. The blobs in a column store are the most voluminous part of your database. It doesn't actually have to reload all that stuff. So the recovery can be pretty quick. Next slide, please. So the timeline for this, it's important to know. So on our managed service, this is already in preview. So it's been in preview since June, and we'll have full release of this capability around the end of September on AWS. And we're a multi-cloud platform. We went on AWS, Azure, and GCP. So Azure and GCP support for point-in-time recovery will come a little later. It should be towards the end of the fall of 2021. That's the target. And then our self-managed software, SingleStore DB, we have released this in June in a preview mode, and it will be ready for general production use in the fall of 2021, and you'll hear a future announcement about that. Next, please. So now let's talk about unlimited storage databases. Unlimited storage is our separation of storage and compute capability for SingleStore. Again, also known as bottomless. And this allows you to scale your storage effortlessly. The way it works is it stores your data outside of the cluster where the computing is done on an external object store like S3, for example. The data is cached locally on the cluster, but the long live data is stored externally. So interestingly, this supports both transactional and analytical applications. This is unique in the industry. There are some other database products out there that have separation of storage and compute for analytical workloads, but no one does it for transactional workloads except SingleStore. So we allow ultra low latency transaction commits with this feature because we don't have to update remote object storage to commit a transaction. You can commit a transaction locally on the cluster, and then the data and the logs are migrated asynchronously out to object storage. So within less than a minute, they'll be pushed out to object storage, but updates are completely local within the cluster so that you can do really fast, like millisecond level commits. So it allows elasticity of storage because your data can grow bigger than the disk space available on the cluster itself. It's unlimited in the sense that cloud object stores have so much storage capacity that for all practical purposes, they're infinite or unlimited in capacity. So that's why we call it unlimited storage. And as I said before, it's really fast. It allows you to do things like, detach a database and then reattach a database to another cluster that might be bigger. And that can happen really quickly. It doesn't have to reload all the database data from the remote storage onto the cluster in order to allow you to start accessing and updating the data again. It just pulls the data in on demand. And that's one of the reasons that, it's really fast to do things like detach and then reattach. Next, please. So the timeline for introduction of unlimited storage databases is the following. So on the managed service, it's already in preview. So actually, let me correct myself. It's in production now on the managed service. So you can create unlimited storage databases that can grow beyond the size of your cluster in production today. So that's available on AWS, and it will be available for Azure and GCP in this fall or very early in the winter. And for SingleStore DB, it was released in the 7.5 release. It's available for production use. Some of the more advanced capabilities that interact with unlimited storage, including point-in-time recovery, are in preview and will be available around the end of September, as I mentioned earlier, for production use. But you can create databases that live on external storage, and the data is cached locally in production today, again, both with our managed service and SingleStore DB. Next, please. All right, so we have evolved our storage technology dramatically in the last couple of years from what we call dual store to a true single store. So in the past, we had two storage structures. We had in-memory row stores, which are best for OLTP, and they can support massive concurrent updates and even sub-millisecond or typically very few milliseconds for response time for doing a retrieval of a row or an update of a row. So go down, please. And after introduction of in-memory row stores, we introduced a disk-based column store that is really, it was always kind of a hybrid of an in-memory row store and a disk-based column store. It had something called an in-memory row store segment to accept the most recent updates. And then the rest of the data was migrated out to disk in column store format. So, and also the column store data is cached in memory in the file system buffer cache for fast access for frequently used data. So this column store storage format was our second storage format. It's best for analytical applications or OLAP type applications. You can store billions to even trillions of rows in this data format. We typically get something like 80% compression. So, only like, the data is like 1/5 of the original size after it's compressed, or sometimes even smaller than that. Next, please. And so we have combined these into what we call universal storage. Really, it's an evolution of our column store technology to handle not just analytical workloads, but also operational or transactional workloads. So it actually really simplifies things, because before people had to create row store tables to do certain types of operations, and then for very large data and historical data, they had to move it into column store tables. And so that involved the application developer having to decide what table to use for what table type to use for what, and then migrate data. Now you can just create a table that uses our universal storage technology, which is just a column store table, and you can do individual row updates really fast and analytics really fast on the same table type. And you don't have to worry about overfilling main memory. The data can be much larger than available RAM for all types of workloads. One nice aspect of this is because you can do analytics on your operational data, since it's in column store format. In some cases, you don't really have to do ETL. You may be satisfied with doing all your analytics on the OLTP schema that you've created and stored in universal storage. This also lowers costs. So one of the reasons we created this technology was to reduce total cost of ownership, because people really like our row store. It's fantastic for the highest performance OLTP requirements. But because all data does have to fit in RAM in a row store, and RAM prices have been relatively high for many years and haven't really gone down, it created sort of a blocker where people couldn't create their largest databases in row store format. Now with universal storage, they can create databases of any size, and the cost of RAM or provisioning enough RAM for the data doesn't block them, because the data can be stored on disk and it's just cached in RAM. And we have really reduced latencies for transactional type application operations, like individual row updates and lookups on universal storage can now be done in just a couple of milliseconds. And it used to take, say, up to 200, 250 milliseconds to update an individual row or find an individual row in a column store segment, which is a million row chunk of a table. So some dramatic technology improvements have been made to make that happen. Next, please. So universal storage is a patented technology. It's really unique in the industry. People just thought that you needed two different kinds of databases. You needed a row store for transactions. You needed a column store for analytics. Well, we've shown that with a enhanced column store, you can handle all kinds of workloads. That's universal storage. And recently, we've added some really big improvements for multi-column key support. So you can now have multiple column unique keys, and these can be used for enforcing uniqueness and also allowing upsert operations, which are conditional insert or update type operations like insert on duplicate key update and so forth. So all upsert type operations can now be done on universal storage tables in SingleStore. And this was sort of the multi-column unique key support and multi-column upserts were the biggest inhibitors to people shifting entirely to use universal storage. So now universal storage is finished. And by that, I mean all the functionality, the basic functional interface that needed to be supported to allow people to run both analytical and operational applications on universal storage. That's all done. So there's nothing holding you back from using universal storage for all your applications, including the ones with very large data and both operational and analytical requirements. Again, I want to reiterate that this really helps improve total cost of ownership for operational type applications on SingleStore, because now you don't have to provision nodes with enough RAM to hold all the data, because the data can be stored on external storage. And it's fast, it's easy to use. You don't have to worry about creating two different tables and migrating data from one table to the other. You can just use one universal storage table. And again, it's patented technology. So thank you. Move to the next one, please. So one interesting thing I'd like to recap is that it's been taken for granted in the industry that you needed special databases and technology for analytical versus operational workloads. As I mentioned earlier, that's not the case anymore. We proved that that's just wrong. So this is really neat in that it reduces cost, complexity, training requirements. It enables building new kinds of applications that you couldn't build before because you might have needed to do operational and analytical operations on one huge table, and that wasn't really that was difficult to do before. And the reason it reduces training requirements is that because now you can do all kinds of things with SingleStore, you don't necessarily need multiple databases to do the application. So you can train your developers on how to use SingleStore, and they can build multiple kinds of apps with that one platform that need to operate at the highest concurrency and scale, provide great transactional and analytical capabilities and multi-model capabilities like JSON, time series, full text, et cetera, all in one database, rather than having silos of expertise within your organization where people have to gain expertise in different products, and you have to have those teams coordinate to build a single application. So timelines for universal storage, all these capabilities I talked about, multi-column key support, multi-column upserts, all became available in the summer of this year for both managed service and SingleStore DB self-hosted software. Next. So with that, I'm going to hand it back to Micah.
Yeah. So couple other features that we've introduced in our managed service platform. The first one is suspend and resume. So SingleStore has always kind of had elasticity built in where you can scale your cluster up or down to meet the needs of your given workload. but we've now introduced a new feature where you can suspend a cluster or resume a suspended cluster, so that if you have workloads that maybe only run for a few days a month for reporting, or maybe you have dev test workloads where you want to shut them down when you're not running them in order to save money, now you can do that easily and automatically through the platform. So it's great for moving new workloads to SingleStore that you wouldn't have run on SingleStore before because of the cost, because you can quiesce them when you're not using them. It lowers your overall cost because you're only paying for what you use. And it also reduces kind of data movement needs. So if you've got a cluster that you want to maybe do development on for a couple of weeks and then shut it down, you don't have to back up that data or move that data to a different storage system while you're not using it. You can just suspend the cluster, all the data is kept in place, and then you can resume it whenever you're ready to continue working on the cluster. So it really gives you kind of greater flexibility to manage your workloads and to manage your costs and to reduce your overall TCO of SingleStore by only paying for workloads when they need to actively run. So this capability is something that we've introduced specifically for the managed service. That was available as of this summer on AWS, and we'll be introducing it on Azure and GCP in the winter timeframe. We've also introduced a new flexible pricing model. So in the past, you would pay for SingleStore based on the overall size of cluster that you had running, and you would kind of run that constantly for the year. And if you wanted to buy additional SingleStore, you kind of had to pay an on-demand price. And so what we've done with our new flexible pricing model is you can predict your monthly spend. So based on the number of clusters that you want to run and the size of those clusters, you can set a level of spend expectation, and you can commit to that to get discounts on the price of SingleStore. But then you can consume that flexibly as compute credits. So I'll talk a little bit more about how this works, but essentially you reserve a certain number of credits and then you burn those down at a discounted rate. And if you want to exceed the number of credits that you have for a month, you can always do that by bursting on demand. So this gives you a couple things. It gives you predictable spend because you know the amount that you've kind of reserved in terms of credits. It gives you true flexibility. So unlike the old completely reserved model where you'd pay for things even if you didn't use them, now you only pay for what you use. And if you have unused credits in the month, you can just continue rolling those over to the following months. So you always get to take advantage of the compute that you've committed to. And you can use these credits across clouds. So if you have multi-cloud deployment or multi-region deployment, you can kind of allocate your expected spend across all your different environments and then burn that down as you run the service and consume credits. So just a couple of details on kind of how our flexible pricing model works. We've got kind of two logical elements within SingleStore. We've got our element of compute, which is the cluster, and we've got our element of storage, which is the database. And clusters, when they run, use credits and burn down credits. And databases are charged at a flat rate based on the region that you're deployed in the cloud. And so what this new credit model allows you to do is to dynamically scale workloads up or down or introduce new clusters and just consume from that pool of monthly credits that you've allocated to SingleStore. And then your database use over time, if that's constant or if that grows in volume over time, you just pay a low flat rate for the underlying storage that's used. And this allows you to kind of separate out the compute workload from the storage costs. And if you've got a workload that spikes up and you need to grow your cluster to add more compute, or maybe you have batch jobs that run at a certain time of day and you want to scale the cluster up and then scale it back down, you can do that completely dynamically and completely separately from the underlying storage that you're managing within the cluster. So gives you true flexibility on consuming SingleStore, but also gives you predictable costs, so you're not surprised by the overall kind of monthly cost of running the service. And this flexible pricing model is something that we've been previewing this summer, and it's available for all customers rolling out this month in August. So you can purchase SingleStore today on the managed service using this flexible pricing model, and you can launch clusters and create databases and that'll just burn down from your allocation of monthly compute credits. And you can also still always buy on demand and just pay for what you use without making a commitment. So the other thing I wanted to touch on is we've put a lot of work into security and compliance for SingleStore and our managed service. This is something that that we looked at from the very start of building the platform. And SingleStore has a lot of customers who are major Fortune 100 companies in financial sectors and security, in healthcare, and our customers have extremely strict requirements around data security. And so this is something that we've designed the architecture around from the start. And this summer, what we announced is that we've achieved a number of security certifications with SingleStore Managed Service. We are SOC 2 compliant. We've reached ISO 27001 certification. And we're also compliant with HIPAA workloads and GDPR and CCPA requirements around data governance. And we've done this by kind of managing security at every level of the platform. So from encryption at rest to encryption at transit, from internal compliance and vetting policies, from restriction of access to the platform and external audit and pen testing. We've gone through all the different steps and integrated all the key technology components in order to guarantee that we have an end-to-end solution with SingleStore that can handle the most trusted data, whether that's healthcare data, financial data, or the key data that powers your business. And we've done this in a way that's enterprise grade and is being used today by some of the largest enterprise customers in the world. So this is something that we announced this summer. It's available now, and you don't have to do anything with SingleStore Managed Service in order to take advantage of the security and compliance measures that we've put in place. This is available across the stack. It's on by default, and data that's loaded into SingleStore Managed Service is always secure and always compliant. So there's a number of key features that we've kind of talked about today, and there's hundreds of other small additions that we've made into the service, new capabilities around programmability, around ease of use, around data management and ingestion. So I would encourage, if you've used SingleStore in the past, I would encourage you to try it again now with the latest capabilities that we've discussed. And if you're new to SingleStore, the best way to try it out is you can go to singlestore.com. You can try it for free today. And our managed service, we actually give you $500 of free credit to launch a cluster or multiple clusters, load some of your own data, and start running the queries and workloads that you've got running on applications today with SingleStore Managed Service, and see the performance and the concurrency and ease of use of consuming SingleStore as a cloud platform, and do that completely free on our platform today. And if you have questions, you can reach out and contact us at managed@singlestore.com. And I think we have some time for a few questions after the webinar too. So Eric's going to be available to answer questions that you have about the features that we've introduced, or just general questions about SingleStore for those of you that are new to the product. Thanks.
Thank you, Mike and Eric. We will now begin the Q&A session. As a reminder, the Q&A function is in the lower right corner of the GoToWebinar console. Here's my first question. Are you going to take away the option to use row store tables now that you have universal storage?
Yeah, I can answer that. Can you hear me okay?
Yep.
Okay. So no, we are not going to take away the option to use row store tables. Row store tables are great for super high performance, sort of transactional type workloads. You can do sub-millisecond updates to records and inserts. It's really great as like a shock absorber for fast inserts and upserts. And so it'll be a tool that we'll continue to maintain indefinitely in the product. So it's not going anywhere, but we think that most application developers will be comfortable using universal storage, which again is an evolution of our column store technology by default, is their first choice, and only for super high performance requirements for OLTP or upsert type operations will they need to consider using Rostar.
Here's the second question. What do you have that's new for app developers, and where can I find out more about that?
Okay, great. Yeah, so we didn't really have time to get into all the things we added for application developers in this summer timeframe, but you can go to our release notes for the 7.5 release. If you just Google the SingleStore 7.5 release notes, it'll tell you all about it. But I can hit some of the highlights. So we have a couple new JSON functions, JSON pretty and JSON build object. JSON pretty prints JSON objects in a nice readable way, and JSON build object is a way that allows you to build a JSON object from data values easily. And then we've also got new functions for creating GUIDs, or globally unique identifiers, or some people call them UUIDs. So there's sysGUID and UUID. One of them gives you a text form of a GUID, and the other one gives you a 16-byte binary form of the GUID. And we know developers, that are building distributed applications need to build, be able to create unique identifiers which can, migrate across systems and still be unique. And so these are popular with developers. And we've got a beta version of an HTTP API that's available. And also, it's funny enough, one of the biggest things people have asked for is emojis. And now we support emojis in 7.5, which is technically it's UTF-8 MB4 or multi-byte 4 character encodings, which includes emojis and some advanced character sets, like in Asian languages, were not completely supported in the past, and now they are. So, if you get people typing in like natural language responses and emojis and like a web application, now you can just like insert that straight into SingleStore without having to like serialize it or something like that. Thinking of some other things. So in 7, we added some stuff recently right before 7.5 came out. It's called temporary stored procedures. So it's a kind of stored procedure that just lives during your session. So if you want to script or program within one session, and then when the session terminates, the procedures go away, it's really useful for that. And this is related to something called anonymous code blocks, which is basically just a script of SQL code that you can run within your session. That it wasn't in 7.5, but it's actually coming out. It should be out by the end of August in a patch release of 7.5. And those two things together, temp store procedures and anonymous code blocks, really open up a lot of neat programmability possibilities, and it makes it easier to script applications with SingleStore.
Awesome. Third question is, can you use unlimited storage databases for self-hosted installations?
Yeah, again, unlimited storage databases, as I said before, it's also known as bottomless. This is our separation of storage and compute. And yes, you can use it for self-hosted installations today on S3 and also on Ceph, which is an open source S3 compatible object store from Red Hat. And so those two are supported now, and in the very near future, we'll support the other public cloud object stores from Microsoft and Google. And yeah, so that's for self-hosted installation. That works.
Here's another question. Can universal storage be used in conjunction with bottomless?
Can universal storage be used in conjunction with bottomless? Yes. Yes, they work together. Completely orthogonal concepts.
Another question is, can you elaborate as to what is stored in S3?
What is stored in S3? I think that probably what that question is getting at is if you're using unlimited storage databases and you're storing your database on S3, what actually goes in S3? So yeah, so all the data eventually winds up in S3. That includes snapshots, which are taken periodically, and they include the in-memory state, like what's in all the in-memory row stores and the in-memory portions of the column store data structures. And then column store blobs are also stored in S3, and the log files from all your partitions. So all that stuff is stored in S3, and it asynchronously migrates from the local disks on the cluster or SSDs on the cluster out to the S3 storage.
Awesome. One more question here is, what's the migration effort to moving from column store to universal storage, and for moving to separate compute and storage?
So what's the migration effort for moving from column store to universal storage? 0. Universal storage is column store. It's an extension of column store it's completely backwards compatible. But I think the more important thing is when you're building new apps, if you're thinking about, you have a large table that you need to be able to do some analytics and some fast inserts, some fast upserts, some fast lookups, you can just start with universal storage.
Any plans to develop Edge DB capabilities?
So we already are used as an edge database. So yes, so because so we can be used in the edge in many ways. Like people, with some of our customers, for example, are in content distribution network business, and they are using us on the edge to track like telemetry from web applications and the state of what content has been cached around the internet, for example. So we have other customers that are using us for video game telemetry. So you can either with our managed service or self-host SingleStore and satisfy edge requirements, and we are very keen on satisfying those requirements. And as we see new things that can make us work better on the edge, we would consider that adding features to make that even easier.
Details on PITR. Does this mean I can go back a month or two and recover the data? Is there any data retention?
Yes, so with point-in-time recovery, it works hand in hand with unlimited storage databases. So when you create an unlimited storage database, you have to set a retention period, which is how much history we retain. And so you could set it to be any amount you want. You could set it for 2 months. You could set it for 2 days, 2 weeks, 2 months, 2 years. It's your choice. And the only thing you really have to be concerned about is, if you're cycling a lot of data through your database, the history can take up, some certain amount of space. So you have to make sure you have adequate, space, or that you're willing to pay the cost of that storage, which is usually storage on remote object stores is usually a nominal cost compared to other costs in your environment. So I think I would feel, very comfortable creating a retention period that was several months or more for most applications.
Okay, I want to thank Micah and Eric for the presentation. I'm sorry, guys, we ran out of time, but we are going to reply to any remaining questions through email. Thank you for attending the webinar today. We will send a follow-up email with today's recording and a link to our managed service free trial. We are offering each user $500 in credit, so you can start a full workload today. Lastly, check out our other virtual events at singlestore.com/events. Thank you for joining us and have a great rest of the day.